Hello. Welcome back to Math 250. I'm the instructor for this course again. Okay, today we're going to continue with some review. So today we're going to do two things. Okay? Today we're going to do two things. The first thing will be a very brief review of quadratics. So the first thing is a very brief review of quadratics. Okay, and this review will be very brief. It'll be just a very short review. Okay, so a very short review of quadratic polynomials. So that's the first thing that we're going to do today. And the second thing that we're going to do today is to review exponents. We're going to review exponents. Okay, so these will be the two things we're going to do today. So first, a very brief review of quadratics. And the second thing is a review of exponents. And let me say something about exponents. So even though this is a review of exponents, and you are all expected to have studied exponents in previous courses, so knowing exponents is a prerequisite for this course. So even though this part is review, oftentimes students need more practice with exponents. Okay, so even though exponents is a review, and it's really a prerequisite for this course, oftentimes students need more practice with exponents. So then on Moodle, I will also upload, in addition to the homework, which I will assign, in addition to homework about exponents, which I will assign, I'm going to also upload some extra practice questions on exponents. I'm going to upload some non-mandatory extra practice questions for exponents. So when you're doing the homework on exponents, if you have trouble with that, then you should also do the extra practice examples, extra practice questions. Okay, so today we're going to do two things. First, a brief review of quadratics or quadratic polynomials, and then we're going to spend most of the lecture reviewing exponents. And this is for many students, not all. Okay, some students will be completely okay with it. But for many students, even though this is prerequisite material, they need more practice with this. Okay? They oftentimes need more reminding of this. Okay? They need more reminding of exponents. Okay, so first we're going to talk about quadratics. So the first thing we're going to discuss is quadratics, or quadratic polynomials. And remember what a quadratic polynomial is. Remember what a quadratic is. Okay, so last time we studied straight lines. Okay, last time we studied straight lines or linear functions. And remember what straight lines are. Straight lines are degree 1 polynomials. Okay, that's what straight lines are. They are degree 1 polynomials. And what's a quadratic? Well, a quadratic is just the next step up. Okay, a quadratic is just the next step up. A quadratic is a degree 2 polynomial. Okay, that's what a quadratic is. It's a degree 2 polynomial. So recall that this is the general equation for a quadratic. The general form of a quadratic is y equals to ax squared plus bx plus c. And we're going to require that a is not equal to 0. Otherwise, it's going to be the degenerate case. Okay, I'll say some more about that in a few seconds. Okay, so recall what quadratics are. So recall the last time we studied straight lines. And straight lines are degree 1 polynomials. And what quadratics is that they are the next step up. They are the degree 2 polynomials, okay, so they have this general form. So recall from school that they have this general form. And recall, roughly speaking, what are the graphs for quadratics. Okay, so recall what are the graphs for quadratics. Okay, recall, roughly speaking, what is the graph of a quadratic. So, so remember, what does the graph of a quadratic look like? So recall that there are two cases. The first case is the case where a is strictly positive. Okay, the case where the highest power coefficient, the coefficient in front of the square term, is strictly positive. And in that case, the graph of a quadratic, roughly speaking, looks like this. Okay, it's curved upwards. Okay, so when the highest power coefficient, the coefficient in front of the degree 2 term, the highest power coefficient is strictly positive, then the graph of the quadratic polynomial, roughly speaking, looks like this. And recall that if the highest power coefficient is strictly negative, then the graph of the quadratic polynomial is basically, it's flipped. It's flipped. It looks roughly speaking like this. Okay, and just for completeness, let's say that we break the rule that a is not equal to 0. Let's say that we break the rule where a is not equal to 0. So we let a to be equal to 0. What do we get? Well, if a is equal to 0, then, so if we violate this condition, then the first term becomes 0, right? Because 0 times anything is 0. So then we get, which is a straight line. Which is a straight line, right? We get this, which is a straight line. So we get back the previous case. We reduce to the case from last time. So that's why we always require that a is not equal to 0, right? Because a is equal to 0 is the degenerate case. Is the case that we already studied, okay? The nicest case. Okay, so that's roughly speaking what the graph of a quadratic polynomial looks like. If the highest power coefficient is strictly positive, then it's curved upwards. It looks like this. And if the highest power coefficient is strictly negative, then it's flipped. Okay, the graph looks like this, and a equals to 0 is the degenerate case. So we always require a to not be equal to 0. Okay, and the main thing that we're going to look at involving quadratics, as I said, this section will be very brief. The main thing that we're going to look at involving quadratics is the quadratic formula. Quadratic formula. Okay, what does the quadratic formula say? Okay, well, say that, again, we're eliminating the degenerate case. We're eliminating the case of straight lines. So the quadratic formula, so we call the quadratic formula from school. The quadratic formula is essentially the solution to the quadratic equation. Okay, remember from school that the quadratic formula is essentially the solution to the quadratic equation. So the solutions of the quadratic equation, and remember what the quadratic equation is. It's where we set the quadratic polynomial to be equal to 0. So the solutions of the quadratic equation ax squared plus bx plus c is equal to 0. Okay, so the solutions of when we set the quadratic to be equal to 0, so that's the quadratic equation. The solutions of the quadratic equation are given by the quadratic formula, which is, to recall from school what it is, it's x equals to minus b plus or minus the square root of b squared minus 4ac divided by 2a. So that's the quadratic formula. It gives all the solutions to the quadratic equation, okay, where we set the quadratic polynomial to be equal to 0. Okay, so let's briefly do one example and then we'll move to exponents. Okay, so here's one example. Find all solutions to this quadratic equation, x squared plus 7x plus 1 equals to 0. Find all solutions to this quadratic equation. Okay, find all solutions to this quadratic equation and use this to roughly sketch the graph. Roughly sketch the graph of the quadratic of y equals to x squared plus 7x plus 1. Okay, so this example asks you to find all solutions to this quadratic equation, and use these solutions to roughly sketch the graph of the quadratic. Okay, let's do this. So to find all the solutions to this quadratic equation, of course, we use the quadratic formula. Okay, we use the quadratic formula. To use the quadratic formula, we need to recognize the coefficients a, b, and c of the quadratic. So what are the coefficients a, b, and c of the quadratic? Okay, what are the coefficients a, b, and c of the quadratic? Okay, so a is the coefficient in front of the square term, is the coefficient in front of the highest power term, so a is equal to 1, right? Because 1 times x squared is x squared. B is the coefficient in front of the x term, is the coefficient in front of the x term, so b is 7. And c is just the constant term, so c is equal to 1. So then we plug these coefficients in front of into the quadratic formula. If we plug these coefficients into the quadratic formula, we get, let me write up here. If we plug these coefficients into the quadratic formula, we get negative b, which is negative 7, plus or minus the square root of b squared, which is 7 squared, minus 4ac, 4 times a times c, so 4 times 1 times 1. Can you see this? I'm just checking to see if you can see this. Okay, it looks like you can see this. And then you divide the whole thing by 2 times a, by 2 times 1. 2 times a, which is 1. Okay, so this is what you get when you apply the quadratic formula. Let me just check to see if you can see this. Okay, it looks like you can see this. It looks like you can see this. Okay, so so then if we do this, we get, first let's simplify the expression inside the square root. Okay, let me erase this first. Let's simplify the expression inside the square root. Okay, let me check one more time if you can see this. Okay, it looks like you can. Let's first simplify the expression inside the square root. If we simplify the expression inside the square root, it's going to be, okay, the expression inside the square root is 7 squared, which is 49, minus 4 times 1 times 1, which is minus 4. So that's 49 minus 4 is 45. So then this becomes minus 7 plus or minus the square root of, and the expression inside the square root sign is 45. Divided by 2 times 1, which is 2. So then these are all the solutions to the quadratic equation. These are all the solutions to the quadratic equation. Okay, so more precisely, the solutions are, there's a plus solution and there's a minus solution. There's a plus solution and there's a minus solution. The plus solution is x equals to minus 7 plus the square root of 45 divided by 2. And the minus solution is minus 7 minus the square root of 45 divided by 2. Okay, so these two are all the solutions of that quadratic equation that I erased. Okay, these two are all the solutions to that quadratic equation that I erased. Okay, let's. Okay, so just checking if you can see this. Okay, so are there any questions about this? Are there any questions about this? Okay, so these two are all the solutions to that quadratic equation that I erased. So this is the answer to the first part of the question. Okay, and by the way, if you use a calculator, you can approximate these two quantities. Okay, you should use a calculator to approximate these two quantities. If you use a calculator, then this quantity is approximately minus 0.15 if you use a calculator. And if you use a calculator over here, this quantity is minus 6.85. Okay, this quantity is minus 6.85. Okay, using a calculator, you can get that this quantity is minus 0.15, and this quantity over here is minus 6.85. Okay, now let's use this information to sketch the graph. Okay, let's now use this information to sketch the graph. let's now sketch the graph using this information. Okay, so towards sketching the graph, recall that the coefficient in front of the highest power term is 1. Okay, this is the coefficient in front of the square term, it's 1, and that's strictly positive. So we know that the quadratic must, roughly speaking, look like this. Okay, the quadratic has to be curved upwards. Okay, the quadratic has to be curved upwards because the coefficient in front of the square term is strictly positive, so the quadratic must be curved upwards. The quadratic must look like this. Okay, so using that, and using the fact that we know that these are the zeros to the quadratic, okay, using this, and using the fact that we know that these are the zeros of the quadratic, we know that the graph has to, roughly speaking, look like the following. So say that this is the x-axis, say that this is the y-axis, and say that this is minus 0.15, and let's say that this is minus 6.85. So these are approximately the zeros of the quadratic. Okay, so we know that these are the zeros of the quadratic. We know that these are the zeros of the quadratic, and we know that the quadratic has to look like this. So roughly speaking, the quadratic has to look like this. Roughly speaking, the quadratic has to look like this. Okay, so this is the rough picture of the quadratic. So this will be y equals to, these will be y equals to x squared plus 7x plus 1. Okay, so this is the picture, this is the rough picture of that quadratic. Okay. Okay, so now let's move on to exponents. Okay, let's move on to exponents. Okay, so any questions? Any questions? Okay, no questions? Okay, now let's move on to exponents. Let's move on to exponents. Okay, so first, let me remind you about the rules for exponents. Let me remind you about the rules for exponents. So the rules for exponents, Okay, so let me just check again if everything is clear. Okay. Okay, so let me remind you about the rules for exponents. Say that A and B are strictly positive numbers. A and B are strictly positive real numbers. And R and S are just arbitrary numbers, any numbers. Okay, so A, B, R, S are numbers, or just any numbers, but you require A and B to be strictly positive. You require A and B to be positive. So the first rule for exponents say that if you multiply two exponents with the same base, it is the same as adding the powers together. So if you multiply two exponents with the same base, if you multiply two exponents with the same base, so these are two exponents with base A, then it is the same as adding the powers together. So this is A to the power of R plus S. Okay? If you multiply two exponents with the same base, so if you multiply two exponents with base A, it's the same as adding the powers together. So this is the same as A to the power of R plus S. So that's rule 1. Rule 2 says that repeated exponentiation is the same as multiplying the powers together. Repeated exponentiation is the same as multiplying the powers together. So if you take a to the power of r, and you take the whole thing to the power of s. So if you repeatedly exponentiate, that's the same as taking a to the power of r times s. Let me write this factor. Okay, so repeated exponentiation is the same as multiplying the powers. If you first take a to the power of r, because you exponentiate once, and then you take the whole thing to the power of s, you exponentiate the thing a second time, then that's the same as taking the whole thing, taking the original thing to the power of r times s. Repeated exponentiation is the same as multiplying the powers together. If you exponentiate by r, and then you exponentiate again by s, that's the same as exponentiating the original thing by r times s. Okay, so repeated exponentiation is the same as multiplying the powers together. Rule number 3. Rule number three says that you can distribute exponentiation over multiplication. You can distribute exponentiation over multiplication. So if you take a times b and you take it to the power of r, that's the same as a to the power of r times b to the power of r. Okay, so this rule says that you can distribute exponentiation over multiplication. You can distribute this exponentiation over this multiplication. So this is the same as a to the power of r times b to the power of r. Okay, so you can distribute exponentiation over multiplication. Rule number 4. Rule number 4 basically says that you can move exponents up and down fractions. You can move exponents up and down fractions, but you need to change the sign of the power. Okay, you can move exponents up and down fractions, but you have to change the sign of the power. So rule number 4 says that a to the power of minus r is equal to 1 over a to the power of r. Okay? Okay. And this rule really says that you can move exponents up and down fractions, but you have to change the sign of the power. Because what does this rule say? Okay, this rule says the following. This a to the power of minus r is the same as a to the power of minus r divided by 1. Okay, that's what this a to the power of minus r is. So this says that you can move the exponents down. You can move the a to the power of minus r down to the bottom of the fraction, but you have to change the sign of the power. So this is the same as 1 over a to the r. Similarly, if you had a to the power of r on the top, if you had a to the power of r on the top, again you can move that a to the power of r to the bottom of the fraction, but you have to change the sign of the power. So this is the same as 1 over a to the power of minus r. So this rule really says that you can move exponents up and down fractions, but you have to change the sign of the power. Okay? Moving exponents up and down fractions is the same as changing the sign of the power. So this a to the minus r, move it down, becomes a to the power of r. This a to the power of r, move it to the bottom of the fraction, it becomes a to the power of minus r. Okay. Okay, so that was rule 4. So next, rule 5. Rule 5 says that if you divide two exponents of the same base, that's the same as subtracting the powers. Okay, dividing two exponents of the same base is the same as subtracting the powers. So if you divide a to the power of r by a to the power of s, okay, so here you're dividing two exponents of the same base. You're dividing two exponents of base a, then that's the same as subtracting the powers. So that's equal to a to the power of r minus s. So dividing two exponents of the same base is the same as subtracting the powers. Rule number 7. Rule number 6. Rule number 6. Rule number 6 says that you can distribute exponentiation over division. You can distribute exponentiation over division. So if you have a divided by b, and you take it to the power of r, then you can distribute this exponentiation over this division. you can distribute this exponentiation over this division. So this is the same as a to the power of r over b to the power of r. So you can distribute this exponentiation over this division, and so this becomes a to the power of r divided by b to the power of r. Rule number 7. Rule number 7 says that if r is not 0, then a to the power of 1 over r is the same as the rth root of a. Okay, it's the same as the rth root of a. Okay, so now rule number 8. Rule number 8 says that, say that r is not 0. No, say that s is not 0. Then a to the power of r over s is the same as a to the power of r, you take the sth root, and that's the same as the sth root of a, the whole thing to the power of r. Okay, so I don't seem to have enough room to write down rules number 9 and number 10 yet. So what I'm going to do is I'm going to go through rules 1 to 8 again. Okay, I'm going to go through rules 1 to 8 again, and then I'm going to write down rules 9 and 10 afterwards. Okay, I'm going to write down rules 9 and 10 afterwards. Okay, so rules 9 and 10 later. Okay, so I don't have enough room for rules 9 and 10 yet. So first I'm going to write down, I'm going to go through rules 1 to 8 again first, and then I'll talk about rules 9 and 10 afterwards. Okay, so let's go through rules 1 to 8 first. So rule 1 says that if you're multiplying two exponents of the same base, that's the same as adding the powers together. So over here, you're multiplying two exponents of base a, and so then that's the same as adding the powers. So it's the same as a to the power of r plus s. Rule 2 says repeated exponentiation is the same as multiplying the powers together. Repeated exponentiation is the same as multiplying the powers together. You take a, and you exponentiate once, so you take it to the power of r, and then you exponentiate again, take it to the power of s. That's the same as multiplying the powers together. So that's the same as a to the power of r times s. So repeated exponentiation is the same as multiplying the powers together. Rule 3 says that you can distribute exponentiation over multiplication. Rule 4 says that you can move exponents up and down fractions, but you have to change the sign of the power. Okay, you can move an exponent up and down fractions, but you have to change the sign of the power. Rule 5 says that if you divide two exponents of the same base, then that's the same as subtracting the powers. Rule 6 says that you can distribute exponentiation over division. You can distribute exponentiation over division, so this is the same as a to the power of r divided by b to the power of r. Rule 7, a to the power of 1 over r is the same as taking the rth root of a. Okay, assuming the r is non-zero. Rule 8, say s is non-zero, a to the power of r over s, a to the power of the fraction r over s is the same as taking a to the power of r and taking the sth root, or taking the sth root of a and taking that to the power of r. Okay, now let me talk about rules 9 and 10. Rule 9 says that a to the power of 0 is 1. A to the power of 0 is 1. Okay, anything non-zero to the power of 0 is 1. That's rule 9. And rule 10 says that if r is strictly positive, if the number r is strictly positive, then 0 to the power of r is 0. Basically, 0 to the power of anything strictly positive is 0. Okay, those are rule 9 and 10. Anything to the power of 0 is 1. Anything non-zero to the power of 0 is 1. And 0 to the power of anything non-zero is 0. Okay, that's rules 9 and 10. They're rules about 0 and 1. They're basically rules about 0 and 1. Okay, let's look at an example. Let's look at an example. Okay, I'm wondering, is the writing still clear? Is the writing on the board clear? Okay, it looks like the writing is clear. It looks like the writing is clear. So let's continue. Let's continue. So here's an example. In this example, say that you're asked to simplify the following expression. Simplify the following expression. Simplify this expression. 4 times x to the power of 5, y to the power of 2, divided by 16, x times y to the power of 4. And the whole thing to the power of 3. They simplified this expression. Okay, let me make sure I wrote it down correctly first. 4 times x to the 5th times y squared divided by 16x times y to the 4th, and the whole thing to the power of 3. Okay, so first simplify this expression. Okay, so the first thing that I would do to simplify this expression is to first simplify the stuff inside the parentheses. Okay, so the first thing I would do to simplify this expression is to first simplify the stuff inside the parentheses. Okay, so towards simplifying the stuff inside the parentheses, 4 divided by 16 is 1 over 4. 4 divided by 16 is 1 over 4, so I get a 4 in the bottom. And then over here, I have x to the 5th divided by x. Or if you prefer, x to the 5th divided by x to the 1. X to the 5th divided by x to the 1. So what is that? That's dividing 2 exponents of the same base. That's dividing 2 exponents of base x. And remember, if you divide 2 exponents of the same base, that's the same as subtracting the powers. Okay? Dividing 2 exponents of the same base is the same as subtracting the powers. So x to the 5th divided by x to the 1 is just x to the power of 5 minus 1. So we get x to the power of 5 minus 1 on the top. Okay, next we have y to the power of 2 divided by y to the 4th. Y to the power of 2 divided by y to the 4th. And again, that's dividing 2 exponents of the same base. Okay, we're dividing 2 exponents of the base y. And again, there's that rule which says that if you divide 2 exponents of the same base, that's the same as subtracting the powers. So y squared divided by y 4th is the same as y to the power of 2 minus 4. Okay, and don't forget to take the whole thing to the power of 3. Okay, so taking the whole thing to the power of 3. So then what rule did we use? We used rule 5. Okay, we used the rule that says that if we divide 2 exponents with the same base, that's the same as subtracting the powers. Now let's clean this up a little bit. Cleaning this up a little bit, this is the same as 5 minus 1 is 4. 2 minus 4 is minus 2. And then we have the 4 in the bottom. And we divide, and we're taking the whole thing to the power of 3. I think we just clean this up a little bit. Okay, next, to clean this up a little bit more, let's bring this y minus 2 to the bottom. Let's make this minus 2 into a positive number. Let's make this minus 2 into a positive number. So to make this minus 2 into a positive number, we can use the rule which says that we can move exponents up and down fractions, but we have to change the sign of the power. Okay, so towards making this minus number into a positive number, cleaning it up a little bit more, we use the rule that says that we can move exponents up and down fractions, but we have to change the sign of the power. So then moving this to the bottom, this becomes x to the power of 4 divided by 4 times y squared, and we're taking the whole thing to the power of 3. So then we just move this y minus 2 to the bottom, and this becomes y squared. And the rule which we used was the rule which says that we can move exponents up and down fractions, but we have to change the sign of the power. So that rule is rule 4, I think. Yeah, it's rule 4. Finally, we can use the rule which says that we can distribute exponents over division and multiplication. We use the rule which says that we can distribute exponents over division and multiplication. So distributing this exponentiation over this division and this multiplication, this becomes x to the power of 4 times 3 divided by 4 to the power of 3 and y to the power of 2 times 3. So we use the rule which says that we can distribute exponentiation over division and multiplication. In particular, we distributed this exponentiation over this division and this multiplication. So we used rules we used rules 6, 3, and we also used the rule which said that repeated exponentiation is the same as multiplying the powers together. Okay, we also used the rule that repeated exponentiation is the same as multiplying the powers together. So we also used rule 2. And then now we can just clean this up. So this becomes x to the power of 4 times 3 is 12. 4 to the power of 3 is 64. 2 times 3 is 6. Okay, let's see if I did this right. Okay, I did this right. Okay, so then that's the answer. Now, by the way, in tests and homework, you don't need to show as much work as I do. I tend to show more work than is needed for pedagogical reasons, right? I'm teaching a class filled with lots of students with varying backgrounds. So then I tend to show more details. I tend to show more steps for pedagogical reasons. But in tests and homework, you don't need to show as many steps. Okay, so note, in tests and homework, you do not need to show as many steps. Okay, in tests and homework, you don't need to show as many steps. However, in tests and homework, you need to show some work. You need to show a little bit of work. Okay, so if you have the answer with no work at all, I'm just going to give you 0. Okay, so even though you don't need to show as many steps as I do, you need to show some work. Okay, so let me give you an example of not needing to show as many steps. For example, you don't need to write down the rules. Don't need to write down the rules. Okay, so in tests and homework, you don't need to show as many steps as I do. I show a lot of steps for pedagogical reasons, but you need to show some steps. You need to show a few steps. Okay, if you show no work at all, if you just write down the answer, you just get 0 points. Okay, but you need to show some work. Okay, maybe just a little bit of work. Show a little bit of work. Okay, let's do another example. Okay, before doing the next example, let's check to see if if my marker is too low, if the marker is clear enough. It looks like the marker isn't too low. It looks like the marker seems clear enough. Let me just switch to a new marker for the next lecture. But let's use the same marker for the remainder of this lecture. Okay, let's look at another example. Example. Suppose that you are asked to simplify the following expression. Simplify this expression. Simplify 2 to the power of 1/3 times x to the power of 1/2 divided by 3 to the power of 2/5. And you take the whole thing to the power of minus 3 over 2. Okay, so simplify this expression. Let me see. Let me first check if I wrote it down correctly. 2 to the 1/3 x to the 1/2 divided by 3 to the power of 2/5, the whole thing to the power of negative 3 over 2. Okay, so simplify this expression. Okay, so the example asks you to simplify this expression. Before doing this, let me give you a little exercise for you to do on your own. And this little exercise will shorten the computation. Okay, let me show you a little trick. Let me show you a little trick that will shorten the computation. So this little trick will help you shorten the computation. So this little trick is an exercise for you to do on your own. So the exercise says that, okay, so this is to shorten the computation. Okay, so this exercise will help you shorten this computation. Okay, that's what this exercise does. It helps you shorten this computation. So this exercise says that if you have a fraction, and you take this whole fraction to a power, say you take it to the power of minus r, then you can change the sign of this power. But to change the sign of the power, you have to flip everything inside the parentheses. So this is equal to, you flip everything inside the parentheses, so b divided by a, and now you can change the sign of the power. So this is to the power of r. Okay, so here's a little exercise, a little trick, and this little trick will help you shorten this computation. What it says is that if you have a fraction, and you take it to some power, say to the power of minus r, so you're exponentiating to the power of minus r, then you can change the sign of this power. But to change the sign of this power, you have to flip everything inside the parentheses. So you flip this fraction, you flip everything inside this parentheses, you get b divided by r, and it's now to the power of r. Okay, you've changed the sign of the power. Okay, so now you use this trick to simplify this computation. So then you can make this power positive, and to make this power positive, okay, by the exercise, to make this power positive, you have to flip everything inside the parentheses. So this is equal to 3 to the power of 2/5 divided by 2 to the power of 1/3 times x to the power of 1/2, and the whole thing to the power of 3 over 2. So this is by this exercise. Okay, so using this exercise, we can make this power positive. We change the sign of this power, but to do that, we have to flip everything inside the parentheses. We flipped everything inside the parentheses. Okay. And now let's continue computing. Okay, so the first thing I would do is I would use the rules which say that I can just distribute this exponentiation over this multiplication, over this division and this multiplication. Okay, I would use the rules which say that I can distribute this exponentiation over this division and this multiplication. So then this expression becomes 3 to the power of 2/5 times 3 over 2 divided by 2 to the power of 1/3 times 3 over 2 times x to the power of 1/2 times 3 over 2. Okay, let me see if I did this right. Okay, so moving from here to here, I used the rules which said that I can distribute exponentiation over division and multiplication. I can distribute exponentiation over division and multiplication. In particular, I can distribute this exponentiation over this division and this multiplication. So I get this. Okay, so the rules I used were rules 6, 3, and 2. Okay, the rules which said that I can distribute exponentiation over multiplication and division, and I also used the rule that said that repeated exponentiation is the same as multiplying the powers together. Okay, I used the rule which said that repeated exponentiation is the same as multiplying the powers together. Okay, and then now all I need to do is clean this up. Okay, just clean this up. If I clean this up, this becomes 3 to the power of 2/5 times 3 over 2. 2/5 times 3 over 2 is 3 over 5. Divided by 1/3 times 3 over 2 is 1/2. 2 to the power of 1/2. And x, 1/2 times 3 over 2 is 3 over 4. To the power of 3 over 4. So then that's the answer. 3 to the power of 3 over 5 divided by 2 to the power of 1/2 times x to the power of 3 over 4. Okay, let's see if I got this right. Okay, so that's the answer. Okay. Okay, let's do the next example. Okay, so solve for x. Where x is greater than 0, and x to the power of 2 over 5 is equal to 3. Okay, solve for the variable x, where x is a number strictly greater than 0, and x to the power of 2/5 is equal to 3. Okay, so this is the question. This is the example. Okay, so let me show you how to solve for this for this x. Let me show you how to isolate the x. So here's the answer. Oops, I hope I didn't kill this. Let me see if this works. Okay, this is pretty good. Here's the answer. Okay, so let me do it first, and I'll explain the strategy in greater detail. Let me do it first, and I'll explain the trick or the strategy in greater detail. So basically, what you do is you take this equation. Okay, you want to isolate the x. You want to solve for x. So what you do is you take this equation, and you take both sides to the power of 5 over 2. So take this equation, take the left-hand side, and you take it to the power of 5 over 2. And then if you do this to balance this, you have to take the right-hand side to the power of 5 over 2. So this is equal to 3 to the power of 5 over 2. And then, okay, so and then over here you have repeated exponentiation. Right? You're taking x and taking it to the power of 5 over 2, and then taking the whole thing to the power of, you're taking x and taking it to the power of 2 over 5, and taking the whole thing to the power of 5 over 2. So over here you have repeated exponentiation, and remember one of the rules is that repeated exponentiation is the same as multiplying the powers together. Repeated exponentiation is the same as multiplying the powers together. And 2 over 5 times 5 over 2 is 1. So you get x, or x to the power of 1, is equal to 3 to the power of 5 over 2. And that's the answer. Okay, so this is, so we used the rule which said that repeated exponentiation is the same as multiplying the powers together. So this is rule 2. Okay, so that's the answer. That's the answer. Now, let me say that in my experience, some students ask me for more details about this step. In my experience, a bunch of students usually, not all, but there are some students which will ask me for more details about this step. So let me explain this computation in more detail. Okay, so this is basically the answer. Okay, if you write this answer down in a test, that's perfect. But oftentimes students ask for more explanation for this step. So let me provide more explanation. Okay, so more. So more explanation. Okay, so here's some more explanation. So basically, what you want to do is you want to solve for x. So you want to isolate this x. This x. So to isolate this x, basically, what you want to do is you want to make this 2 over 5 into a 1. Right, to isolate, okay, so you're given this thing, and you want to solve for x. You're given this stuff, and you want to isolate the x. You want to solve for x. And x is the same as x to the power of 1. So you want to change this 2 over 5 to a 1. You want to change this 2 over 5 into a 1. So the strategy is you want to make x to the power of 2/5. This 2/5 over here, you want to make this 2/5 into a 1. Into x to the 1. Not because x to the 1 is the same as x, because x to the 1 is the same as x. So once you have x, you've isolated the x, you've solved for x. So what you want to do is you want to make this 2 over 5 into a 1. Okay, so you're given this stuff, and you want to make this 2 over 5 into a 1. And here's the trick. The trick is to use rule 2. Use the rule which says that repeated exponentiation is the same as multiplying the powers together. Okay, you use rule 2, which says that repeated exponentiation is the same as multiplying the powers together. If you take a and exponentiate by taking it to the power of r, and exponentiate again by taking it to the power of s, that's the same as a to the power of r times s. Repeated exponentiation is the same as multiplying the powers together. So in particular, so that's the trick that you do to make this 2 over 5 equal to 1. So basically, you solve for the equation 2 over 5 times s is equal to 1. So what times 2 over 5 will be equal to 1? And the answer is s equals 5 over 2, right? Because 2 over 5 times 5 over 2 is 1. 2 over 5 times 5 over 2 is 1. So what do? You exponentiate both sides by 5 over 2. Exponentiate. So take both sides to the power of 5 over 2. Take both sides to the 5 over second power. So that's what you do. So you take both sides to the 5 over second power. So you take this side this side to the power of 5 over 2, this side to the power of 5 over 2, and then by rule 2, repeated exponentiation is the same as multiplying the powers together. So this is x to the power of 2/5. Let me make a little bit more room. X to the power of 2/5 times 5 over 2. That's rule 2. Right? By rule 2, repeated exponentiation is the same as multiplying the powers together. So this is the same as x to the power of 2 over 5 times 5 over 2. And 2 over 5 times 5 over 2 is 1, right? That's how we chose 2 over 5 and 5 over 2. 5 over 2, 2 over 5 times 5 over 2 is 1. So then this is just x to the power of 1, or this thing. So x to the power of 1 is is 3 to the power of 5 over 2. Okay, so that's how you get the answer. Okay. Any more questions? Any more questions? Okay, so if you don't understand, just ask me during office hours. Okay, just ask me during the Zoom office hours. Okay. Okay, let's do one more example. Let's do one more example. Okay, solve for x, where x is greater than 0, and 7 times the 5th root of x over 3 is equal to 2. Okay, solve for x, where x is some positive number, such that 7 times the 5th root of x over 3 is equal to 2. Okay, so solve for x. Okay, so here's the answer. So again, what I'll do is I'll just write down the answer straight, and I'll give a little bit more explanation. I'll give a little bit more explanation afterwards. Okay, so here's the answer. So first of all, towards isolating the x, we want to isolate the x. Let's divide both sides by 7. So we divide both sides by 7, we get the 5th root of x divided by 3 is 2 over 7. Okay, so we just divide it, we just remove, towards isolating the x, we just remove the 7 from both sides. So we divide by both sides by 7. And now, remember, one of the rules says that the 5th root is the same as taking to the power of 1 over 5. So this is the same as x over 3 to the power of 1 over 5. I don't remember what rule this is. This is rule 7. By rule 7, this is x over 3 to the power of 1 over 5. And then, what I'm going to do is, okay, so we have x divided by 3 to the power of 1 over 5 is equal to 2 over 7. So what I do is I take both sides to the 5th power. I take both sides to the 5th power. So I take x divided by 3. Okay, so let me just write x divided by 3 over 1/5 is equal to 2 over 7. Okay, that's what we have from here. X over 3 to the power of 1/5 is equal to 2 over 7. And I take both sides to the 5th power. And again, I'm just writing down the answer. I'll give you a little bit more explanation again in a few minutes. Okay? So take both sides to the 5th power. So take this side to the 5th power, and take this side to the 5th power. Okay, take both sides to the power of 5. Take both sides to the power of 5. I think this should be 5. Okay? And over here, again, we have a repeated exponentiation, right? It's x to the power of 3. It's x divided by 3. And we exponentiate by taking it to the power of 1/5, by taking it to the power of 1/5, and we exponentiate again by taking it to the power of 5. So we have a repeated exponentiation, and remember the rule. The rule says that repeated exponentiation is the same as multiplying the powers together. So this is the same as this thing to the power of 1/5 times 5. 1/5 times 5 is 1. So it's x to the power of x divided by 3 to the power of 1, which is just x divided by 3 is 2 over 7 to the power of 5. And you can leave your answer like this. And leave answer like this. But if you want, you can simplify it in some way, like you can plug it into a calculator. If you plug into a calculator, this is approximately 0.0057. Okay, and over here we used rule 2. Okay, repeated exponentiation is the same as multiplying the powers. Okay, and again, the key thing over here is, why did I take this equation and take it to the power of 5? And again, we're using rule 2, which says that repeated exponentiation is the same as multiplying the powers together. So, okay, so basically we want to make this 1 over 5 into a 1. So so the strategy is to first solve for 1 over 5 times what is equal to 1? What times 1 over 5 is equal to 1? And the answer is 5. 5 times 1 over 5 is 1. So then we take both sides to the power of 5. We take both sides to the power of 5. Then in this left-hand side, we have a repeated exponentiation. So then by row 2, repeated exponentiation is the same as multiplying the powers together. So by row 2, by row 2, which says that repeated exponentiation is multiplying the powers together, this is just x divided by 3 to the power of 1 over 5 times 5. But then, what was 5? 5 was the number that we chose, so that if we multiply 1 over 5 by 5, it's equal to 1. So this thing is just x to the power of 3 to the power of 1, which is just the same as x to the power of 3. It's x divided by 3 to the power of 1, which is the same as x divided by 3. Okay, so then that's, oops, I made a mistake over here. This isn't the answer. To get the answer, you have to clear out the 3. So then x is equal to 3 times 2 over 7 to the power of 5. Sorry. And then, and so then we get this, and then it's easy to isolate the x now because you just remove the 3, multiply both sides by 3. So that this is approximately, and this is approximately 0.0057 using a calculator. So you can leave the answer like this. Can leave answer like this. Okay. So I finished this example. Okay. So then are there any questions? Okay. Then I've finished today's lecture. Okay. So then thank you. Have a nice day.